I will talk about the application of AI. AI is like artificial intelligence in meteorological research. So we'll focus how can we utilize the AI in the era of data science, and it is very helpful for weather forecasting and any other researches. So let's get started for today's lecture. So this is the outline of today's lecture. So first of all, we need to know the data type, okay? So in the real cases, we have mainly two types of data. One is categorical data, another is continuous data, okay? So what is the categorical data? I will talk later. So if we have the categorical data, then we can do two tasks in using AI. One is classification, another is clustering. So what is the classification? I will talk later. And classification, for example, we can predict storm types, different types of storm, category 1, 2, 3, 5, etc. And the cloud classification, different types of clouds. Even we can identify like cluster different types of data in similar items, like identifying the climate patterns. If we can identify the climate patterns and we cluster or we make a group, then clustering weather events, etc., we can do that if we have a categorical data. And the second one is the continuous data. Okay, so if we have continuous data, then we can do two tasks: regression and the dimensionality reduction. Okay, so regression we use for statistical or machine learning model to predict the continuous data sets, like depending on the independent variables, we predict the dependent variables, and we can see the relationship between dependent and independent variables. Okay, so regression, so for example, we can do temperature prediction, humidity forecasting, etc. And the second one is dimensionality reduction. So for example, principal component analysis. So by using this method, we can use reduce complexity in large data set. If you have the large data sets and if you have the many factors in a data set, so you need to remove the irrelevant data sets and you need to keep the most important features in your data set. Then you can forecast accurately. Okay, and finally I'll talk about the Python technical support, because you also need to know how you can use the machine learning and deep learning model, that is the AI model, in your cases. Okay, so I will give you hand notes on TensorFlow, that is the deep learning library, and the scikit-learn is a machine learning library, how to install this thing, how to use, and how you find the tutorials, like you need to write some course. So everything I will provide at the end of this lecture, like Python technical support. So I think you can hear me, right?
We can hear you.
Yes, okay. So if something happened in something wrong, so you can notify me. Okay. But if you have any questions, you just keep notes. Okay. After end of this lecture, I will give you time to ask some questions. Okay. But I think this is a very important lecture for this summer IMSHA lecture series, and I think you can utilize the AI in your research and you can get a better job. Okay, anyway, let's continue. So now, what is the categorical data, right? So categorical data is like data grouped into distinct categories or labels. It is qualitative rather than numerical. So this is something like, if you say the weather types, then you can classify as like sunny, cloudy, rainy, snowy, foggy, etc. if you say in the storm categories, then hurricane categories, hurricane, typhoon, tropical cyclone are the same thing. So like category 1 to 5. So based on the maximum sustained wind speed, we can categorize different types of typhoons. Okay. So in that case, we use classification or clustering. Okay, I'll talk later. And the cloud types, different types of cloud, the cumulus, stratus, cirrus, nimbus, etc., etc. Then for the wind direction like north, south, or east, west, or northwest, east, west, different directions we have. Then for the climate zones, we can classify like tropical, temperate, polar, different climate zones. Then we need to use the classification or clustering. Okay. So precipitation types. For the precipitation types, we can classify like rain, snow, hail, sleet. So these are the categorical data. Okay. But if you have the continuous data, what is the continuous data? In the other hand, so continuous data is like a numerical data with infinite possible within values, like within a range, typically measured. We can analyze mathematically, we can use model, etc., etc. So numerical is a continuous. So for example, for the temperature, we can measure the temperature in degrees Celsius or Fahrenheit, etc. For the humidity, how much moisture in the atmosphere. So we often use like percentage, say for the 50%, 50% relative humidity in the atmosphere, like this. So wind speed, we measure in meters per second, or like kilometers per hour, or miles per hour. Even the atmospheric pressure, we can measure in millibars, or the hectopascals. And if we want to measure the precipitation amount, then we can use like in millimeters or inches. So this is a continuous data. Okay. Then the application in AI. So what is the application in AI? For if you have the categorical data, either we can classify or cluster. We classify different types. Even a cluster, if we have the similar group, like same characteristics, we make a group or cluster. Say for example, here for the classification, if you want to forecast the hurricane types based on the maximum sustained wind speed, so you can have a data in Excel file, like you can have like data, or you can have from the base track data that we get from Joint Typhoon Warning Center, or IB tracks, or etc. So you have an Excel file, then differently you have the maximum sustained wind speed, and based on maximum sustained wind speed, you can classify in the category 1, 2, 3, 4, 5, like this, 3 or 5. Then you can also classify if you have the infrared image, like satellite image. From the satellite image, you can also classify. So this is the classification. Use the CNN model, convolutional neural network model. This is the deep learning model. So here, like this is the typhoon I, or within this 300 kilometers or 500 kilometers, you can extract, you can cut with the AI model. Then you can find this data, you can find the maximum sustained wind speed, then you can categorize. Okay, by this way you can classify hurricane types. These are application of classification. Okay, you can also use AI for the other areas in meteorology to classify. Okay, then we can also cluster. So in clustering, what I said before, if you have a similar types of data or feature, you can group them together. Like for the tropical cyclones, we have some straight moving cyclones that goes straight. Say for example, that go straight, and some not straight, is recurve and go eastward. Okay, so there are two types, mainly two types, like recurver. One is recurve and go east way, and another is like go westward. Okay, this is a straight moving. So there are a lot of cyclones. Maybe if we have 100 years or 50 years data cyclones, and you want to categorize them, you want to cluster them, who you want to cluster the state moving cyclones, the one cluster, maybe recurving another cluster, or the different types of cyclones. So based on this clustering, their characteristics, their structure, and their relationship with the large scale environment or other factors is different. So you want to cluster them, then you want to analyze, and it's helpful to forecast typhoons. Otherwise, if you just use a cyclone data and you want to forecast, then it's very difficult. So the state moving and recurving, their characteristics is different. Their environment, large scale environment, their factors, the ocean and air factor are different. So that's why we use the clustering method. For the AI model, its most popular is K-means clustering. So you can use the K-means clustering method to cluster your tropical cyclones, or if you have the another data, not only the tropical cyclones, you can use a different data. If you have in meteorology, you just cluster them. Okay, so you need to understand the purpose. All right, so now if you have the continuous data, it can be in special map. You can have like either continuous data, it can vary based on space and time. So if you have the special map, like in meteorology, we have some, say for example, let's CDF file, 3-dimensional or 4-dimensional, we have time, let, long. So in the special map, the data is very on time. This is the time sheets data. Even you can use the map in AI model. This use like ISO index forecasting. Okay, using the CNN model. This is adapted from the Ham et al. 2009. They published in Nature. So if you have the time, like the current time, previous 2 months, they use the input as a SST or ocean heat, maybe heat current. Yeah, ocean heat current. They use two types of variable here, and as input they use some location for the like Nino 3.4 region, then extract with the CNN and CNN analyze, and finally they forecast the Nino 3.4 with the 1 to 23 months. So you can use the special map in the AI model. But please note that if you have the special data, like for the image processing, if you have the image or satellite image or any special map, then it's better to use the deep learning model. Deep learning model, especially like CNN, convolutional neural network, or long short-term memory or other, but CNN is the best model for the image processing. So if you have the special map, then it's better to use the deep learning model. Okay, deep learning model only, mainly based on for the image processing. Okay, even if you have time series data, say for example, this is like PDO index forecasting. PDO index forecasting use gated recurrent unit GR model. So if you have the time series data like this original sheet, this is a PDO index, you can download online. So if you have the time series data in Excel file, even still you can use it to forecast. So in this paper, they decompose first different, the in time series data, there are three components like trend, seasonal component, and residual. So you can read this paper. I give the link. So even if you have the time series data, we can use different model. Not only the GRU, you can use CNN, SBM model, random forest model. There are different types of models in AI, like machine learning or deep learning. If you have the time series data, then you can use and you can forecast. Okay, and but the model performance varies data to data. So you need to test first which model is best for your data. But if you have the time series data, you can use AI. Even if you have the special map like the image, you can also use the AI, okay, for the regression. Then we can also reduce the dimensionality. Like if you have large data sets, say for example, is a one example, the monthly variation in environmental variables. There are a lot of variables like minimum air temperature, maximum air temperature, minimum water temperature, etc., 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 and it varies monthly. So there are a lot of factors, but all factors may not be important for your analysis, or maybe not relevant to the main factor or the target factor. Okay, then for example, we use principal component analysis, PCA. We call this PCA. So we find the principal component, most important factors that we need for our analysis. So we use this. If we have the continuous data, then we can reduce the dimensionality. Okay, here's one example like PCA. Then now we know if we have the categorical data or the continuous data, we can use the AI. We will use many models that exist in the TensorFlow and scikit-learn library, right? But we need to evaluate the model performance, how models work. Okay, so for this case, we use some metrics. Like for the classification metrics, we either use accuracy or precision recall or F1 score, ARC or ROC, like area under the curve, confusion matrix, etc., etc. So I gave the link. I will share the PPT. No worries. So we use this matrix to see the how they classify. If they misclassify more, then they will get the punishment. So you can see the accuracy, how the accuracy, maybe accuracy 90%, 80%, or 70%, 50%, how the accuracy, how they classify accurately. Then we can say, okay, this model is good or this model is best. So you have the true level, then the predicted level we can see. Okay. Then for the clustering, it's the most important. You need to select the optimum number of cluster or appropriate number of cluster. We use different types of metrics to evaluate. Okay, like to find the optimum number of cluster, we use logarithm likelihood, sum of square error, or Silhouette score, etc., etc. So there is an example in scikit-learn is Python example like Silhouette analysis here showing two cluster, so different. So if you have the many data, you can put 5, 6, 7, 8, 9, 10, then it will find out how many clusters is best for your data. Okay, this is just an example. You need to find more. Okay, so I will just give you the way, and later on you just use this link and follow this tutorial, and you can use your own data. Okay. Then, okay, for the regression matrix, if we perform the regression, then we can use different metrics like correlation coefficient, mean absolute error, Nash-Chat clip efficiency, etc., etc., etc. Here is an example that adapted from the Hu et al. 2020, who focused the PDO index, okay, from 1 to 23 months. ENSO index focused 1 to 23 months ahead. So they compared different types of models. You can see the different types of model. Among them, you can see which model is the residual CNN. This model is performed better. P23, the correlation scale is too high, is high, like it can focus till 20 months, 0.5, this is 0.5. So till 20 months, it focused very well. Okay, the correlation is like the observed relationship between observed and predicted. So how the predicted value are closer to the observation data. This is the correlation scale. We know this correlation. Okay. Then, sorry. I mistakenly Click here. I'm sorry, mistakenly I clicked somewhere. Okay, so we are here, right? Hello.
Yeah, doctor, we can see.
Yeah, hello. All right.
Yeah, we see.
Okay, so even for the dimensionality reduction, if there are different types of metrics, like if we use the principal component analysis, the explain variance ratio, reconstruction, trustworthiness, stress, etc. There are a lot of metrics. So you can use in Python this metrics. This adapted from Objet Kumar. It shows the Python code, and using this metrics, you can know how your model perform. Okay, that's the thing. Now we need the technical support, the real example. Okay, we need to install TensorFlow and scikit-learn. TensorFlow is dedicated to deep learning model, and scikit-learn is a machine learning model. But if we install the TensorFlow, then scikit-learn is there together. So we don't need to install scikit-learn more. So we can copy this link. Okay, I will share this PPT. Copy. Okay. So you can install TensorFlow with pip, but there are different platforms. So if you want to use the Linux, then Linux, Mac, or Windows native, you just Windows or Windows subsystem, CPU, etc. So the best way, like we use mostly Windows, right? Hello? Hello? We use the Windows, right?
Yeah, doctor, we use.
Yes, Windows. Then check if you have the NVIDIA. If you have the NVIDIA or other like GPU system, then it's better because GPU is more faster than the CPU. But if you don't have the NVIDIA like GPU system, don't worry. Then you can also use. The most important is you need to install the Miniconda. You have the Anaconda and the Miniconda. Anaconda is large. There are a lot of libraries, a lot of softwares installed in Anaconda. Okay, but we don't need the more softwares to install in our system. So that's why we use a Miniconda Windows install. So Miniconda just lighter than the Anaconda, and it will take the less space in your C drive. So you install the Miniconda, then we need to create an environment like TensorFlow. So then you just follow this step. You type the conda, create the name, like we are creating an environment TensorFlow, and then Python 3.9 should be, because we are using the Windows is best, this is stable. When you create, then we deactivate, then we activate the TensorFlow, because we need to activate this environment. Then if you have the GPU already NVIDIA, then you just conda install, then this sudo nn you just install. Then after that, but if you don't have GPU, don't worry, you just go directly pip install, upgrade pip, then you install the pip, upgrade the pip, then pip install TensorFlow. Okay, and you can verify if your CPU or GPU, whatever, this is the best way to install the TensorFlow. Okay, then you can enjoy the machine learning and deep learning more. Okay, now we need to find out the tutorial, because we are beginner. Maybe we don't know anything about the AI, even we don't know the code. So I started in machine learning mastery. He's my teacher, not directly, but I learned from his tutorial. He's a very good guy. Even we had some emails. I had some problems in my PhD. I sent him email, and he's a very good guy. He's in Australia, and he's a founder and engineer of machine learning mastery. And he made, can you imagine, he made all the tutorials is free in online, and lot of Python course. It's it's very surprising. Anyway, you can see this mastering machine learning. Machine learning mastery is there. So this is a website. There you will find the tutorials, but I will give you the direct link for the tutorials so you may begin. So one example I can show you, as I will share the PPT, so you can copy the link later, or maybe the old link I will give you in my video description on my YouTube channel. It's okay, so I can give you there. Anyway, so provide an example. Okay, so how to compare a time series to supervised learning. This is one tutorial. He explained everything like a babish. Okay, then with Python code and explanation. You'll not find such kind of tutorial in anywhere. Okay, you can see the Python code is free, even with explanation in detail. So one is to podcasting. This code is ready. You just change the data. Even to follow this tutorial, there is a dataset, sample dataset. You just download from this link. By this way, you can learn the AI and use AI in meteorological research. I learned from this website. Machine Learning Mastery is free. Okay, and that's all. 谢谢。